Hey guys, today I'm going to be talking about Advanced Mathematics, Basic Integration. It's a part of the HSC module and it's the opposite to differentiation. I hope you've already learnt differentiation. If you haven't, then this part isn't for you. You should go back and learn differentiation, or wait until you learn differentiation at school, then come back to integration. You can still do it without learning differentiation, but it's a lot easier if you do learn differentiation first. Okay, so let's see some rules. In integration, what you're doing is, as I said before, the exact opposite of differentiation. So there are a couple of rules that make this a lot easier. Suppose I had, okay, now I'll explain some stuff to you. This, which looks like an F, is the integral symbol. It's not an F. The C is a constant, and the dx means in respect to dx. It can be anything. It could be like, yx, anything. But in this case, it's in respect to dx, just to show you some examples of the rules. So first off, if I had anything like this, a to the power of n dx, what we'd do is we'd just add 1 to the power and put it over the new power that we added 1 to. So, and plus the constant. Never forget the constant. You should always remember the constant. Well, that's basically the first rule, and I'm sure it will come all to light when I do some examples. The second rule is that if there's just any digit by itself, then that digit turns into its digit plus, well, adding on with x. So if there was just k, it would turn into kx, and then the constant at the end. And then now suppose we had ax plus b all to the power of n. What we'd do is that we'd plus 1 to the power of n, and we'd times it by a, which is the integer in front of the x with the new power. Okay, these are some fairly simple rules, and I'm only doing basic integration because I myself haven't really delved into the harder parts of integration yet. Well, anyways, let's go down and do some examples, but first off, I want to show you something. In integration, you have two things, something which are definite integrals and indefinite integrals. Now, why I say this is that it will really actually help you when you're doing any integral question, or just help you identify what you're actually doing. So first off, in a definite integral, it looks something like this. So that's our integral symbol, and we have two numbers, suppose 4 and 1. And then we have a normal integral thing, so like, 4x plus 3, and it's in respect to dx. That is a definite integral. Now, let me explain to you why it's a definite integral. This is a definite integral because when we actually solve this, there is no longer a constant. It's definite, it has a boundary of 4 and 1. Whereas an indefinite integral is just the integral symbol, and then something like 4x plus 3 in respect to dx. The only missing thing in these two is that number, these two numbers, are only in definite integrals. So that's how you define definite and indefinite integrals. Okay, now I'll just solve both of these just to give you a quick overview of how both of them work. So in this one, all I'd do is I'd write that, and 4 and 1, so all I have to do is see these ones? I have to convert these into, I have to integrate them. So we get 4x squared over 2 plus 3x in respect to dx. And then see this 4 and 2, that can make our life a little simpler. So, so we just get that 2x squared plus 3x dx. Now what I'll do now is I'll go on to actually minus the 4 and the 1 while subbing it in. So now all I'd do is something like, since it's 2x squared, so I'd go 2, and then I'd do 4 squared plus 3 to the 4 minus the exact same as the other one, except summing in the 1 now. Squared plus 3, 1. Okay, cool. So that's pretty much it, and I'll just chuck it into my calculator now. And that should equal 39. Cool. So that's how you do the definite integrals. Now I'm just gonna erase this for a bit, and you can just like see it if you can just rewind and have a look at it if you need to. But now I'll show you what indefinite integrals are like. Okay. Whoa, redo, undo, undo, undo. And I'll just go back to here. Okay, cool. No worries. Let's just ignore that. Let's go to the indefinite integrals. So indefinite integrals, the exact same thing, except now you have to account for the constant. So we get 4x squared over 2 plus 3x plus c. That is the main difference. And then you just solve it like normal. So then you get 2x squared plus 3x plus c. Now you don't actually know what the c is, so you probably have to include it in your answer. That's all I needed to actually explain to you guys about definite and indefinite. Now we can move on. So let's do some examples. I'll do I, and I'll do I of question 2 and question 3. You can do the rest if you really want to. Okay, cool. So in I, we've got f2x minus 1 dx. So this is with respect to dx, and this is an indefinite integral, as you can tell. Okay, so you get 2x squared over 2, and we get minus 1x in respect to dx. Perfect. See how I didn't actually follow the last rule? I didn't follow this rule, and a lot of people get confused. The main reason I didn't follow that rule is because this is to the power of n, whereas in here, there is no power to anything. It's just a plain integral with nothing like that. So we can just use the normal integration rules. Cool. So now we can get rid of dx. We have to add a c. So we get this final statement. So we get 2x squared over 2. Oh, well, you can cancel them out, and you just get minus 1x plus c. So that's what I'd confirm my thing with, and let's check if this is correct. Let's quickly. Okay, it's correct. So well done. Just walk through it to me, and it's fine. It's perfect. Let's move on to the next one. Okay, now this one is a definite integral. So here we go. I'm really sorry if my math isn't the best. I'm not the best at math, so just bear with me. I'm just trying to learn a little bit as I go along. So okay, here we go. We've got f, 2 and 1, which are our boundaries, and we've got 3x squared in respect to dx. It's always good to deconstruct the question if you have time, and let's just have a look at what we can do. So these definite, since it's a definite integral, we're going to have to minus the two things that we end up getting. So okay, let's integrate this. How convenient. We can cut across these two out in respect to dx. Perfect. Now you end up getting something like this. It's always good to just write it in this notation type form, and you get 2 and you get 1. Okay, cool. Now I can just chuck it in. So 2. It's always the higher in front of the above the lower one. That's how it's always ordered. If it's anything different, then it should be. I'd never expect that to happen. It usually never does happen. Okay, now 2 and we have 1, so 2 to the cubed minus 1 to the cube. And let's have a look at what it equals. So 2 to the cube obviously is just 8, and we've got minus 1, so because 1 to the cube is just 1, so it should equal 7. Okay, that concludes the 2 examples. Feel free to do the others and test your stuff out, and just let me know if you ever need any help. Thanks.